ಪ್ರೀತಿಯ ವಿದ್ಯಾರ್ಥಿಗಳೇ, once again welcome back to DC machines and alternators class. This is one of the very important subject in your electrical and electronics program. Why? Because electricity generation, both DC and AC, explained in this subject. Direct current is generated using DC generator and alternating current is generated using alternators. Nowadays, without electricity, no operation, nothing, including mobiles, computer, laptop, all factories, irrigation motors, everywhere electricity is required. That electricity generation concept, machine used, everything explained in this course. In the last class, we studied about the commutations. In this class, we will discuss about how to improve the commutation process, methods of improving commutations in DC generators. We already discussed what is commutator. Commutator is used to convert AC generated voltage in the armature conductors to DC for external load. That means its function is like rectifiers in electronic circuits. The process by which current in the short circuited coil is reversed while it crosses the magnetic neutral axis is called commutation. The brief period during which coil remains short circuited is known as commutation period TC. We already studied this sketch. Here, this is a commutator. This one brush. This collects the current from this commutator. Here also you can see real DC machine, stator part, rotor part, commutator segment and brush assembly. In this video, you can see how spark generated in the machine. In this area, you can see the sparks here. This is commutator segment, brushes. Here also you can see. Diagram helps to understand the commutator, armature winding. This is the armature winding, commutator segment, field poles north and south, and brushes. It collects the current from the commutator, EMF induced from the armature winding. This diagram is also we studied during the commutation process. In the last sketch, spark comes even though the brush shifted from this B commutator segment, current jumps from B to this brush. In this diagram also you can see actually plus 20 to minus 20 current change, but due to bad commutation, still 5 amps current is pending in that particular coil because of poor commutation. Next, Methods of improving commutation. The main problem for delayed or bad commutations are listed here. One is mechanical problem, another one is electrical problem. Mechanical problems can be minimized by different methods. One is replacing worn out bearings. ತುಂಬಾ ಸಮಯದಿಂದ ಯೂಸ್ ಮಾಡಿದಿದ್ರೆ ಬೇರಿಂಗ್ಸ್ ಸ್ವಲ್ಪ ಹಾಳಾಗಿರ್ತದೆ, ಕೆಟ್ಟೋಗಿರ್ತದೆ, ಅದನ್ನು ಬದಲಾಯಿಸಬೇಕಾಗ್ತದೆ. ಬೇರಿಂಗ್ಸ್ ಅಲ್ಲಿ ಬಾಲ್ ಬೇರಿಂಗ್ ಅಥವಾ ರೋಲರ್ ಬೇರಿಂಗ್ ಇರ್ತದೆ. ಸಿಮಿಲರ್ಲಿ ರಿಪ್ಲೇಸಿಂಗ್ worn out ಬ್ರಷಸ್, ದೀರ್ಘಕಾಲದ ಬಳಕೆಯಿಂದ ಬ್ರಷಸ್ಗಳ ಸಹ ಹಾಳಾಗಿರ್ತದೆ, ಸೌದು ಹೋಗಿರ್ತದೆ, ಅದರಿಂದಾಗಿ ಸ್ಪಾರ್ಕ್ ಬರೋ ಚಾನ್ಸಸ್ ಇರ್ತದೆ, ಅದನ್ನು ಬದಲಾಯಿಸಬೇಕಾಗ್ತದೆ. Adjusting spring tension in the brush holder. Brush placed inside the brush assembly. That assembly consists of spring also, because while rotating, brush is stationary, commutator is rotating. You have to apply the pressure on the brush to collect the voltage from the commutator. So proper pressure also very important. You have to adjust that. Next, smoothing the commutator surface. Due to the long use, commutator surface also ಡ್ಯಾಮೇಜ್ ಆಗಿರೋ ಚಾನ್ಸಸ್ ಇದೆ. ಅದನ್ನು ಕರೆಕ್ಟ್ ಮಾಡಿ ಕ್ಲೀನ್ ಮಾಡಿ ಯೂಸ್ ಮಾಡೋದ್ರಿಂದಲೂ ನಾವು ಈ ಸಮಸ್ಯೆಯಿಂದ ಹೊರಗೆ ಬರಬಹುದಾಗಿದೆ. These are the mechanical problems ಅನ್ನು ಸಾಲ್ವ್ ಮಾಡೋ ಬಗೆ. Next, electrical problems can be minimized by two methods. One is resistance commutation, another one is EMF commutation. In detail, you have to study about this resistance commutation and EMF commutation. Resistance commutation. In this method, low resistance copper brushes are replaced by high resistance carbon brushes. We already discussed brushes material usually copper ಅಥವಾ ಗ್ರಾಫೈಟ್ ಅಥವಾ ಕಾರ್ಬನ್. ಕಾಪರ್ ಬ್ರಷ್ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಅದರ ರೆಸಿಸ್ಟೆನ್ಸ್ ಕಡಿಮೆ ಇರ್ತದೆ, ಕರೆಂಟ್ ಈಸಿಯಾಗಿ ಫ್ಲೋ ಆಗ್ತದೆ. ಬಟ್ ಕಮ್ಯುಟೇಷನ್ ಪ್ರಾಬ್ಲಮ್ ಇಂದಾಗಿ ನಾವು ಇಂಪ್ರೂವ್ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ ಬೇಕಾದ್ರೆ, ಕಮ್ಯುಟೇಷನ್ ಪ್ರಾಬ್ಲಮ್ ಅನ್ನು ಇಂಪ್ರೂವ್ ಮಾಡೋದಕ್ಕೋಸ್ಕರ ಕಾಪರ್ ಬ್ರಷ್ ಅನ್ನು ಬದಲಾಯಿಸಿ ಕಾರ್ಬನ್ ಬ್ರಷ್ ಯೂಸ್ ಮಾಡೋದ್ರಿಂದ ಚೇಂಜ್ ಮಾಡಬಹುದು. ಯಾಕಂದ್ರೆ ಕಾರ್ಬನ್ ಬ್ರಷ್ ಹ್ಯಾಸ್ more resistance. Here you can see the armature coil. Here in this side current left to right, here right to left. Here current path, commutator segments and brushes. Current I comes from the left side, current I from the right side, total current 2I. In the center current is Y. So in this path I plus Y, here I minus Y. This area resistance is R1, this area resistance is R2. If commutator or rotor is rotating left to right, then area of the brush in contact with the bead decreases. As the area decreases, resistance increases. Here also we can see the resistance R1 is increasing, whereas R2 is decreasing as the segment moves. That means you already studied formula for resistance, R equal to rho L by A, where rho is coefficient of resistance, L is the length in meter, A is the area of cross section. That means more the area, resistance is less. Lesser the area, resistance is more. Here area as the moment of the commutator left to right, area connected to the B segment of the brush reduces. If area reduces means resistance increases. Current from Ohm's law, current is directly proportional to the 1 by R. So as the resistance more, current decreases. Here current decreases, so all the current passes to coil B only. So it helps to reduce the commutation time or delay in commutation. The current I coming from the coil C has to pass through segment B and to the brush I minus Y. The coil B and to the brush via segment A, it's Y. The resistance of the first path is very high compared to the second path. Hence, current will flow through the second path, and thus current through coil B reaches its maximum value before the end of the commutation. ನೋಡಿ ಇಲ್ಲಿ ಇದು ಕಮ್ಯುಟೇಟರ್ ಲೆಫ್ಟ್ ಇಂದ ರೈಟ್ ಗೆ ಮೂವ್ ಆಗ್ತಾ ಬರ್ತದೆ ಈ ಕಮ್ಯುಟೇಟರ್ ಸೆಗ್ಮೆಂಟ್. ಆಗ ಈ ಬ್ರಷಿನ ಏರಿಯಾ ಕಾಂಟ್ಯಾಕ್ಟ್ ಆಗಿರೋದು ಕಡಿಮೆ ಆಗ್ತದೆ, ರೆಸಿಸ್ಟೆನ್ಸ್ ಜಾಸ್ತಿ ಆಗ್ತದೆ ಇನ್ ಕೇಸ್ ಆಫ್ ಕಾರ್ಬನ್ ಬ್ರಷ್ ಯೂಸ್ ಮಾಡಿದಾಗ. ಆಗ ಇಲ್ಲಿ ಬರುವ ಕರೆಂಟ್ ಕಡಿಮೆ ಆಗಿ ಎಲ್ಲ ಕರೆಂಟ್ ಇಲ್ಲಿಗೆ ಹೋಗ್ತದೆ. ಭಾರಿ ಕಡಿಮೆ ಅವಧಿಯಲ್ಲಿ ಕಾಯಿಲ್ ಅಲ್ಲಿ ಹರಿಯುವ ಕರೆಂಟ್ ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್ ಆಗ್ತದೆ. ಸೊ ಕಮ್ಯುಟೇಷನ್ ಡಿಲೇ ಇನ್ ದಿ ಕಮ್ಯುಟೇಷನ್ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಆಗ್ತದೆ ಬೈ ರಿಪ್ಲೇಸಿಂಗ್ ದಿ ಕಾರ್ಬನ್ ಬ್ರಷಸ್ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಕಾಪರ್ ಬ್ರಷಸ್. So based on these two formulas, R equal to rho L by A and current directly proportional to the 1 by R. These advantages of carbon brushes, not only it improves the commutation, other advantages also. It helps to improve the commutation due to high contact resistance. We already discussed that. Another advantages, with graphite, carbon brushes will have self-lubricating property. Hence, it smoothens the commutator segment. Separate lubrications not necessary if you use the graphite or carbon brushes. Thereby, the contact improves between the commutator and the brush. Also, it smoothens the commutator segment. In the event of spark, carbon damages the commutator less compared to copper. Small amount of spark also makes big problem sometimes. But copper brush kinta carbon brush use ಮಾಡಿದಾಗ ಕಮ್ಯುಟೇಟರ್ಗೆ ಆಗುವ ಡ್ಯಾಮೇಜ್ ಅನ್ನು ಸ್ವಲ್ಪ ಮಟ್ಟಿಗೆ ಕಡಿಮೆ ಮಾಡಬಹುದು ಅಂತ ಆಗ್ತದೆ. So these are the advantages of carbon brushes over copper brushes. Next, EMF commutation. Resistance commutations which discussed, now EMF commutation. In this method, the main reason for delayed commutation is eliminated. That is, reactance voltage is eliminated. Hence, this method is called voltage commutation or EMF commutation. This can be achieved by two ways. One is shifting the brush method, another one is interpole method. We already discussed reactance voltage. That means coil has inductance. It opposes the change in current. That's why delayed commutation. That reactance voltage opposes the change in current. We can remove that reactance voltage. We can by using the interpole method or by shifting the brush method. By shifting brush methods, you can see here This is the A original brush position. Next, A plus B shifted from here to here. This position to this position, shifted. Thereby, we can overcome that reactance voltage problem and improve the commutation. In this method, the brushes are given sufficient forward lead to bring the short-circuited coil. That means coil undergoing commutation under the influence of next pole of opposite polarity. Since the short-circuited coil is now in the reversing field, the reversing voltage produced cancels the reactance voltage. Thereby, the delayed commutation problem is somewhat eliminated or reduced. Next, interpole method. Interpole also called comb pole. Interpole is a pole between the main pole. For example, north, this one, and south pole to main pole. This north and this south interpoles. In this diagram, we can see the connection of interpoles. For example, plus this is the armature, this is the armature, this is the main pole, this is the interpole. Carefully see, from the plus terminal, connection is to the interpole, then to the other interpole, then to the brush commutator segment, then armature winding, then to the negative. That means interpole winding is connected in series with the armature winding. Very important. Interpole winding is connected in series with the armature winding. The polarity of the interpole is in such a way that here is N. So main field pole ahead of this is north pole. So interpole polarity is north. Similarly, here main pole polarity is south, here south. See, north and south pole depends on the connections. Carefully, for example, here winding is anti-clockwise. By seeing from this side, that means by viewing from this side, anti-clockwise, if then it is north pole, like this, north pole. In this case, by ಈ ಕಡೆಯಿಂದ ನೋಡಿದಾಗ clockwise current ಹರಿತದೆ, then it is south pole, like this, south pole. You have to remember that if current direction changes means the polarity also changes. Electromagnet ಹೇಗೆ north pole ಆಗ್ತದೆ, ಹೇಗೆ south pole ಆಗ್ತದೆ, depends on current in the winding. Similarly, in the interpole, with the anti-clockwise directionally current ಹರಿದಾಗ ಇಲ್ಲಿ ನೋಡಿದ ಹಾಗೆ ನಾರ್ತ್ ಪೋಲ್ ಆಗಿ ಆಕ್ಟ್ ಆಗ್ತದೆ. ಕ್ಲಾಕ್ ವೈಸ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಹರಿದ್ರೆ ಅದು ಸೌತ್ ಪೋಲ್ ತರ ಆಗ್ತದೆ. ದಿ EMF induced due to this interpole helps to overcome that reactance voltage, thereby it improves the commutation. Once again, interpoles are pole between the main poles. Here, two pole machine, so two main pole and two interpoles. In case of four pole machine, four main poles, four interpoles. In this method, the main cause for delayed commutation is neutralized. Interpoles are also called commutating poles or auxiliary poles or comb poles. Interpoles are defined as small auxiliary poles placed in between the main poles, connected in series with the armature, and have the polarity same as that of main pole ahead of it in the direction of rotation. ಅದರ ಮುಂದೆ ಇರುವ ಮೈನ್ ಪೋಲ್ನ ಪೊಲಾರಿಟಿಯೇ ಆ ಇಂಟರ್ ಪೋಲಿಗೆ ಇರುತ್ತದೆ. ಮುಂದೆ ಇರೋದು ನಾರ್ತ್ ಪೋಲ್ ಆದರೆ ಅದು ನಾರ್ತ್ ಪೋಲ್, ಮುಂದೆ ಇರೋದು ಸೌತ್ ಪೋಲ್ ಆದರೆ ಅದು ಸೌತ್ ಪೋಲ್ ಆಗಿರ್ತದೆ. ಮತ್ತು ಇಂಟರ್ಪೋಲ್ನ ವೈಂಡಿಂಗು ಆರ್ಮೇಚರ್ ವೈಂಡಿಂಗ್ಗೆ ಸೀರೀಸ್ ಅಲ್ಲಿ ಕನೆಕ್ಟ್ ಆಗಿರ್ತದೆ. ದಿಸ್ ಇಂಟರ್ಪೋಲ್ ವೈಂಡಿಂಗ್ helps to neutralize the reactance voltage. Advantages of using these interpoles are: it improves the commutation as the armature conductor undergoes commutation. Commutation is delayed due to the production of reactance voltage in it, which opposes decrease in the armature current. But interpoles produce a voltage which will oppose the reactance voltage, thus it improves commutation. Other than this also, some other advantages also, in case of armature reaction also, it helps to overcome that problems. So summarize these methods of improving commutation. Mechanical problems can be minimized by replacing the worn out bearings, replacing the worn out brushes, adjusting spring tension in the brush holder, smoothing the commutator surface. That means by taking the proper maintenance work regularly, we can eliminate that mechanical problems. Electrical problems can be minimized by two methods: resistance commutation by using high resistance carbon brushes instead of copper brushes. Another method is EMF commutation using the interpoles. Next, we will practice some multiple choice questions related to the methods of improving commutations. First one, interpole flux should be sufficient to options: A, neutralize the commutating self-induced EMF. Option B, neutralize the armature reaction flux. Option C, neutralize both the armature reaction flux as well as commutating EMF induced in the coil. Option D, perform none of the above functions. So carefully observe the options and select the correct options. Next question, in DC generator, interpole winding is usually connected. Options are: A, in series with the armature winding, B, in parallel with the armature winding, C, in series with the load, D, in parallel with the load. Here also understand the question and options, select the correct options. Next question, the main function of interpoles is to minimize dash between the brushes and the commutator when the DC machine is loaded. Options are: A, friction, B, sparking, C, current, D, wear and tear. So select the correct options. Next question, the most likely cause or causes of sparking at the brushes in DC machine is or are. Here cause or causes of is or are. That means one correct answers may be one or more sometimes. Options are: open coil in the armature, B, defective interpoles, C, incorrect brush spring pressure, D, all the above. Here read all the options and choose the correct. Sometimes All the above also correct. Then select that answer. Point out the wrong statement in DC generators. Commutation can be improved by option A, using interpoles. Option B, using carbon brushes in place of copper brushes. Option C, shifting brush axis in the direction of armature rotation. Option D, none of the above. Here also, see the question carefully. Point out the wrong statement. If first statement is correct, don't select the A is the correct answer. So negative type of questions here. Carefully choose the answer. Next question. Which voltage is neutralized in voltage commutation process? Options are A, armature, B, reactance, C, field, D, cannot be determined. So select the correct answer. Next, multiple choice questions on methods of improving commutation. Interpoles are excited with the dash. Options are A, armature current, B, field current, C, separate supply, D, main current. Select the correct answers. Next options under improving commutation. Each of the following statements regarding interpoles is true except options are A, they are small yoke fixed poles placed spaced in between the main poles. Options B, they are connected in parallel with the armature so that they carry part of armature current. Option C, their polarity in the case of generators is the same as that of the main pole ahead. Option D, they automatically neutralize not only reactance voltage but cross magnetizing as well. So read once or twice all the options and questions and finalize your answer. Next multiple choice question. In a DC generator, in order to reduce sparking at brushes, the self-induced EMF in the coil is neutralized by all of the following except options are A, interpoles, B, dummy coils, C, compensating winding, D, shifting of axis of brushes. Here also read the questions 2 times, then select the correct answer. Next multiple choice question. The material for brushes is generally option C, mica, B, copper, C, cast iron, D, carbon. Most suitable choice you select. Another multiple choice question. In DC generators, the polarity of the interpoles options are in the same as that of the main pole ahead. Option B is the same as that of the immediately preceding pole. Option C is opposite to that of main pole ahead. Option D is neutral as these poles do not play part in generating EMF. So try to understand the question and options. Select the correct answer. Once again, to answer all these multiple choice questions, theory knowledge is very, very important. So go through theory portions once again, then answer the questions. So during the sessions, we studied commutations, how to improve the commutation process. Okay, thank you all. Happy learning.